The product property says that if you are taking the log of a number that can be broken down into factors, for example, 30 is 10 times 3. It can be broken down into two factors. You can split that log into an addition problem where you break it up into the two factors. So it would be log of m plus log of n. Sometimes you want to split it up. Sometimes you want to combine into one log, depending on what the problem is asking. You just have to know the property so you know to use it. That is on the wall over there above the two arrows that we used for difference in sum of cubes over there by Alvy. On that wall over there by the hats. Product property. Quotient property is very similar, but it is when you find the log of a number that can be divided. What do you think we're going to do with the two logs we break it up into? Subtract it. Very similar to how we deal with exponents. That's also on the wall by Alvy, above, right under the word SOHCAHTOA on the wall. Quotient property. The third property, which is my favorite, is the power property. And it occurs when you're taking the log of something to a power. So the log base b of what I have written there is m to the p. When you're taking the log of something to a power, that power can be dropped in front like a leading coefficient, effectively moving the exponent from one level down to the regular level of the problem. That's on the wall over by the flag, right above that picture that's hanging on the wall.
The flag.
Yeah, it's in the way. We can roll it up during the test. So those are your three properties of logarithms that we're going to spend the rest of the hour practicing. Okay? I will show you a few, and then we're going to do several examples of you using them, simple and more challenging, to get you, used to it. Here's example number 1. We are going to solve for x. All right. In the problems that we have already done, we had one log on each side, and we ignored it. You can only do that when you have one log on each side. Log this equals log that. In this problem, we have 3 logs. You can't do that. So what we want to do is we want to try to get this problem back to one log on each side using the properties that I just told you about. My first step will be that 3. It's in the way. So what I'm actually going to do is I'm going to move that 3 up to the power using the power property. And I'm just writing them off to the side just to describe what I'm doing. You've seen that done before in your old buddy, the 2-column proof. Okay, you don't have to write those down, but that's just what I'm doing for you, is describing what I'm doing. Now, I am going to turn the left side into one log using the quotient property. So I'm going to go from 2 logs to 1 log. If you look at the property, you can go from 2 to 1 by going from subtraction to 1 log of division, or you can go from 1 to 2, depending on what you're looking for. At this point, the problem looks like a problem that we did several days ago, where we had 1 log on each side. That was our goal, the first 2 steps, was to get back to something we already know, just by using the properties that I just showed you. So I moved the 3 up, kind of just to clean house a little bit and get it to look like a quotient property, because it was in the way. Then I did a nice clean quotient property. Now I'm ready to ignore my log base 5s. And now I'm not in this chapter anymore. Simply have to solve for x, and everything's good. Multiply by 4, take the cube root. Cube root of 64 is 4. You have to check to make sure that 4 does not lead to taking the log of a negative number. And when you put 4 in, it obviously works because it's the log base 5 of 4. So you're good. This one is completely different for many reasons. What do you see? What are we going to have to do?
It's the
Product property, very good. So we can go ahead and do that on the left side. We're going to have to multiply the x times the x minus 12. Okay. It's good if you saw that. I can distribute the x. Now, if you look at that, and you think this, you're wrong. That is not correct. Because you cannot just ignore 1 log. The only time you can ignore a log is when you have a log on each side. So what we have to do is rewrite the logarithm as an exponential. So that's going to be this whole process. 8 to the 2nd power equals x squared minus 12x. Okay? It's a very common mistake that kids make. They'll want to ignore 1 log because they won't see that it's 1 instead of 2. 8 squared is 64, which is a quadratic. And now we would try to factor that using the monkey method or the quadratic formula, whatever you want. Factors into kind of an oddball one, x minus 16, x plus 4. The 2 solutions that we can get from that are 16 and negative 4. And the only one that works when you put them in is 16. Let's try again. All right, this is a very simple one. I want you to try it and see if you can come up with the answer all by yourself. Product property should be log base 3 of 5n. Ignore the logs. Divide by 5. N equals 30. Let's try another simple one. Let's build some more confidence. Try that one. All right, so this one should be simple in the sense that you should reach a point where you are saying to yourself, 42 divided by what is 6? Well, that's mental math. All right, you can upside down and flip things and go crazy, but in the end, that's basically what you're saying. 42 divided by what is 6? And the answer is 7. Make it more difficult. We're going to skip that one. Going to skip that one. Try that one. Solve for x. Step 1, I'm going to move the 2 up. Now I'm going to use the product property to get 1 log on each side. Ignore the logs. Divide by 3. X squared equals 25. Then we get x equals 5. Plus or minus 5, but negative 5 doesn't work. So we simply take positive 5 right there. Step 1, we're going to have to use the product property to multiply and get x squared minus 6x. Then we don't have a log on each side, so we have to rewrite it as an exponential. 4 to the second equals x squared minus 6x. That's 16. So I move it over. Now I have a quadratic, which factors. My 2 answers are 8 and negative 2, and negative 2 doesn't work. So my answer is 8. I showed you how to do this earlier in the chapter by giving you a shortcut. And we did it that way. We rewrote it as a logarithm and just figured out that log on our calculator. Log 7 divided by log 4. But these problems can get complicated to the point where you can't use the shortcut. So I'm going to show you another way to do it using logs that will allow you to do the complicated ones as well. Okay? And the way to do that is, when you see the equation, the first thing you do is take the log of both sides. So log 4 to the x equals log 7. You can do whatever you want to the equation as long as you do it to both sides. So I'm just deciding here, I'm going to take the log of both sides. What that does, since logarithms have a power property, is it allows you to take that x and move it down front. So now we have x log 4 equals log 7. And now you can divide both sides by log 4, which is the same calculation we made to get the 1.404 on the right side. Like I said, we already had a way to do that. I'm showing you taking the log of both sides for a reason that you'll see in a minute. Log of both sides, exponents come down front, and then you solve accordingly. Okay? Here is the example I'm talking about. 8 to the 2n equals 52 to the 4n plus 3. I want to know what number I would put in for m so both of those sides are exactly the same. The n's cannot be up in the exponent. I cannot solve for them up there. So my first plan is to take the log of both sides. Log of both sides. What that allows me to do is it allows me then to take the exponents and bring them down as leading coefficients using the power property. So I have 2n log 8 equals 4n plus 3 log 52. That's the key part of the problem that we're learning today. That right there. The rest of this problem, which you'll see, is not today's material. Power property, log of both sides, then take the power property. Then what I'm going to do to get back to something that I really am comfortable with, I'm going to use my calculator, and I'm going to write decimals for log of 8 and log of 52. Okay, I just typed them into my calculator. Log 8, log 52. And now, that thing, as nauseating as it looks, is just a simple Algebra 1 solving equations. There's nothing algebra triggish about that problem. It looks gross, but it's just an equation. So step 1, log of both sides, which allows me to move the powers down. I did 2 logs on my calculator, and now I'm in Algebra 1. So on that left side, I would multiply those two numbers together, 2 times 0.903. On the right side, I would distribute the 1.716 through the parentheses. Simple Algebra 1 maneuvers. Now I have to get the ends together. So I'm going to subtract that 6.864n over to the left, which would give me this, and then divide by negative 5.058. And you get that.